The last type of problem before we get to the word problem is this. We're going to use inverse matrices to solve a system. So you know a bunch of ways to solve a system right now. Elimination, substitution, graphing, and another one. But what we're going to do is we're going to use inverse matrices. So pay close attention to this. Okay, people get confused with this. But basically this, you could take any system of equations and make a matrix equation out of it. Okay? What you're going to have is this. You're going to have one matrix times another matrix equals another matrix. Look, here's the equals, alright? And you put these two on the end. These are the constants. So your constants will go here. 19 and -7. This first one are all of your coefficients. This is called your coefficient matrix. Alright, all of your coefficients go here. What numbers with the variables, right? 2, -3, that's 1x, and that's positive 4y's. What do you think this will be then? What are we missing? We're missing the x's and the y's, right? So this is x, this is y. So this is your variable matrix. Alright, so basically you can break any equations down into a matrix equation. Okay? Now, why does this work? Because let's say, well, this is being multiplied, right? Let's say I would take this row times this column. What would that be? 2 times the x, 2x. -3 times the y, there it is, equals the first guy, 19. That row makes an equation itself, okay? So, but we don't have to multiply because I know this multiplied is just this, okay? So all you have to do is this. What do you want? You want x. What is x equal to? And what is y equal to? That's what you want to know, right? You got plenty of ways to solve it. All we have to do is this. If I want to get this guy, this matrix by itself, x and y by itself, we need to get rid of that matrix right there. So, we need to get rid of this matrix. How do you get rid of this matrix? We already learned this. How do you get rid of that? Let's call that matrix A. How do you get rid of it? You multiply it by the inverse of A. So whatever this is, you multiply by the inverse and it goes away. This times its inverse is basic. It's kind of like 1, right? It goes away. And you're going to be left with x and y after you multiply these two together, right? This will be left over. It's kind of like this. 2/3 x equals whatever you want. Alright? I want x by itself, just like I want xy by itself, right? But I need to get rid of this. How do I get rid of that? Find the inverse of that, which is 3/2, and I multiply it on both sides. Okay? Same thing here. I'm going to find the inverse of this, and I'm going to multiply it here, and it goes away, just like I multiplied here, and these go away. You're left with x. I multiplied here, these go away, I'm left with xy is equal to whatever this is. Remember what I told you, always multiply in the front. So since I'm taking A inverse on this side, multiplying on this side, I also have to multiply it on this side, but it has to be in the front right here. It can't be right here. Remember, matrix multiplication is not commutative. So basically I'm just going to write this. The inverse of A times that by 19 -7. You just need to find out what the inverse of A is. Alright? So, what do? Find the inverse of A. Take this guy and find the inverse. So 1 over the determinant. 8 minus -3 downward minus upward, which is 1 over 11. Oh, it's going to be ugly, but that's okay. And then remember we flip these two, that's 4, that's 2, and we make these opposites. So that's +3, and it's -1. So the inverse is actually this times this. So I'm going to do that in my head and write it down here. 111 times 4, 4 elevenths. 111 times 3, 3 elevenths. 111 times -1 is 1/11th, and 1/11th times 2 is 2/11ths. All you have to do now is take this times this. That's really all it is in the beginning. Take whatever the inverse of this is and multiply it on this side, and you're going to get your answer. Okay? You're going to get your answer right here. You just got to do a little bit of work. Remember, row times a column. So, take this row times this column. 4/11ths times 19 plus 3/11ths times -7. -1/11th times 19, 2/11ths times 7, and you're going to get two numbers right here. Okay? So let's recap real quick. Take this, make a matrix out of it. Coefficient matrix times variable matrix, xy, equals these guys, 19, -7. Now, what they have here, you should pay attention to this. AX equals B. This is like matrix A. This is like matrix X equals matrix we call B. So basically, how do you get X by itself? We multiply, just like a normal question. We would multiply both sides of the equation by the inverse of this, right? Times that by A inverse. And these two basically go to 1 almost. Okay? Multiply this side by A inverse, and that's it. These cancel, and you're left with X equals whatever these two are. Find the inverse of A and multiply to this guy, to B. And that's your answer. Let's look on here. So here's the process of finding A inverse. I showed you this, and here's A inverse. And then, so here's what you see. It used to be A -1 here, X times this. So, but this is just 1, the identity matrix right here. Okay, so basically you just take A inverse times B, and really you got your answer. X equals, so you take this row times this column, and you're going to get 5. I'm just going to assume you can do this by yourself. And take this row, this column, and you're going to get 3. You have to know how to do it by hand. Ready? Alright, so what does that mean? 5, 3 equals XY, because that's what it was equal to. XY matrix. What does that mean? 5 equals X, -3 equals Y. So you could write on your paper 5, -3 is our answer. Okay, that's X, that's Y. Okay, that's it. Solution is 5, -3. Know how to solve a system using inverse matrices. Alright.